Hello, and welcome to This Explainer. Look, if math sometimes makes you feel a little intimidated, I just want you to take a nice deep breath. We've got this. Math really isn't about memorizing scary formulas. It's actually just a way of organizing the world into logical boxes. Think about how a shopping app sorts items to give you a discount, or how a surveyor measures land for a building design, or even how your smartphone organizes all your photos and data into albums. That is literally all set theory is. It's just sorting information. Today, I'm going to be your private tutor, and we're going to master universal sets and subsets together. So let's dive right in.
I always think it's way better to look at a shape or a pattern before we even think about touching a formula. So take a look at this diagram. We've got a big box labeled teeth set, and inside of it there are smaller boxes for incisors, canines, premolars, and molars. Now, if I were to ask you where the canines are, you'd naturally just say, well, they belong inside the larger group of all teeth, right? See, you already understand the logic perfectly. The specific teeth naturally just fit right inside the whole group.
Now, what's super interesting is how we give that exact same logic a mathematical name. That whole group, the big box that holds absolutely everything we're currently talking about, that's called the universal set. It's basically the main parent group. And why do we even need this? Well, to sort things properly, we first have to know the absolute boundaries of the world we're sorting. We typically draw it as a big rectangle and we label it with a capital U or sometimes the Greek letter mu. It essentially just gives all of our smaller groups a logical home.
Let's ground this with another real-world example. Imagine we want to study various groups of people living in the state of Telangana. In this scenario, what is our big container? What's our universal set here? Well, it's the set of all people in India, because every single person in Telangana naturally fits inside that much larger container of India. Makes sense, right?
And this brilliantly illustrates how this exact same logic applies to numbers. Just look at these circles. Before we even worry about definitions, just follow the visual pattern. The inner circle is n for natural numbers, 1, 2, 3. Notice how that entire circle fits perfectly inside w, the whole numbers, which really just adds a 0. And then, both of those circles sit comfortably inside the giant rectangle R, the real numbers. The visual literally tells the whole story before we've written a single equation.
So the absolutely crucial point here is knowing how to actually write this relationship down. That is where our symbols come in. When one group fits completely inside another, we call it a subset. The symbol kind of looks like a sideways U with a little line under it. It just means all elements of the first set are present in the second. But if the bigger set has extra elements, meaning the smaller set is strictly smaller, we call it a proper subset, and we just drop that bottom line.
Okay, pay close attention here, because this is a massive exam alert. The most common mistake I see students make under exam pressure is mixing up these two symbols. They panic and they just guess. Don't do that. Always pause and ask yourself, does the parent set definitely have more items? If the answer is yes, it's a proper subset, just the sideways U. No line underneath.
Let's practice. Easy, medium, and hard examples.
You're doing great. Now that we have the visual logic and the symbols down, we're going to build up your confidence by solving 3 examples step by step. Let's start easy. Step 1. What is given? Well, we have set V, which contains the vowels A, E, I, O, U. And we have set A, which is all the letters in the English alphabet. Step 2. What is asked? They want to know the relationship between V and A. So, step 3, let's solve it. Every single vowel is inside the alphabet, and the alphabet definitely has extra letters, right? So V is a proper subset of A. Super easy. Now let's step it up a notch and look at the try this exercises directly from your material. I want us to look at question number 1 in that bottom box together. It's all about quadrilaterals. Let's break this down just like a tutor would. Step 1, what's given? Set A is all types of quadrilaterals, so literally any four-sided shape. Set B is a specific list: square, rectangle, trapezium, rhombus. Step 2, what's asked? The question wants to know, is A a proper subset of B, or is B a proper subset of A? Basically, which one fits inside the other?
Step 3. Let's solve it. Just think back to our logic boxes. A square is a type of quadrilateral. A rectangle is a type of quadrilateral. Every single shape in set B naturally fits perfectly inside the massive universal container of set A. Therefore, B is a proper subset of A. You really just have to figure out which is the big container and which are the smaller items.
Okay, take a deep breath. Here is a hard board exam level question. Step 1. What's given? Set A is prime numbers less than 10, B is odd numbers less than 10, and C is even numbers less than 10. Step 2, what's asked? Which of the following complex statements is true? Now, step 3 is the absolute secret to never failing these. Do not try to solve this in your head. The biggest mistake students make here is rushing. You literally must write out the elements first.
Let's unpack them together. What are the prime numbers less than 10? Set A is 2, 3, 5, 7. What are the odd numbers less than 10? Set B is 1, 3, 5, 7, 9. Evens less than 10? Set C is 2, 4, 6, 8. Look at how much easier the problem becomes the second you make the numbers visible. So, the first option asks, is A a subset of B? Let's check our lists. Are all the numbers in A also hiding inside B? Well, look at the very first number in set A. It's the number 2. Now look at set B, the odd numbers. There is no 2 in there. Because 2 is a prime number, sure, but it is definitely not an odd number. Since 2 is missing, A simply cannot be a subset of B. It just doesn't fit in the box.
Now let's skip down to option 6 on that list. It asks, is the null set, represented by the symbol phi, which looks kind of like an O with a slash through it, a subset of A? Now, this is a massive exam trap, but if you know the rule, it's a totally free point. The answer is yes, and that actually leads us directly to a very powerful shortcut.
Your 5-point exam cheat sheet.
You did wonderfully on those problems. See, math really is just organizing boxes. Let's lock in everything we've learned to make sure you walk into your next exam feeling completely bulletproof with this quick 5-point cheat sheet. Number 1, the universal set, denoted by U or mu, is always your big parent container. 2, a subset means all elements from the first group match elements in the second. 3, a proper subset means it completely fits inside a parent that has extra items. 4, always write out your elements before answering multiple choice questions. And 5, the null set, or phi, means an absolutely empty set.
And here is your surprise trick to instantly solve tricky multiple choice questions way faster in exams. The empty null set is a subset of every single set in existence, no exceptions. Also, every set is technically a subset of itself. If you memorize those 2 facts, I promise you can instantly cross out trap answers on your exam without doing any real calculations.
I want you to visualize that null set as an invisible, empty box that somehow fits perfectly inside every other box you will ever draw. If an empty box is technically everywhere all at once, it kind of makes you wonder what else is hiding in plain sight in math, doesn't it? If you remember that invisible box, and you remember to physically write out your numbers before you solve, you are absolutely going to ace this topic. Keep practicing, stay calm, and I'll see you in the next explainer.